Equation of line given 2 points. Question 5. We are midway in our set to find equation of line given 2 points. Now normally I work with very simple numbers because I don't like to use calculators. But in true life you have to deal with fractions, correct? They're tough. And fortunately you have calculators to work with, so that's not so difficult. But in this I'll try to show you the concept, how to deal with fractions while plotting points. That is more important. Calculations, I know you can use calculators, plus well, these are simpler numbers to work with, so they are not that complicated. So the idea is to understand the concept. Okay, question 5. Find equation of line through the points a minus half minus 2 and b 3 by 4 and 3. So you see I've just made x coordinates as fractions to scare you, right? But the idea is to get friendly with them. Let's first try to plot them. And I've seen even grade 11 and 12 students struggling to plot such fractions on a coordinate plane. Now the thing is, when you look at such points, you should see which is the lowest common denominator, I mean the lowest number, or which is the fraction, which is the lowest fraction, I should say. And when we say lowest fraction kind of thing, okay, let me put it the other way. So when you have fractions involved, you should look at the denominator first. So this is like 1/4 and this is like halves. So 1/4 is kind of smaller, so our unit should be easy for 1/4. Okay, so we'll go with units of 1/4, correct? So what I will do is, first let me write this point in my 1/4. So that's a new idea which I'm giving you. It is going to help you in doing such problems. So 1/4 is my idea. So I'm saying a, if I write it in 1/4, it becomes minus 2/4, correct? So that's same as minus half, right? And this is like minus 2, and my point b is 3/4, so that's correct, 3/4 and 3. So that is how I see my points as. So that's itself a brilliant idea, right? Now, well, you may or may not change a question like this, but that's just an idea. Now to plot it, let's plot point A first. So normally we say divisions of 1, 2, 3, 4, let's call them 1/4. Isn't that interesting? So let's say this division this time is not 1, but it is 1/4, correct? And since it is minus 2/4, minus 2/4, we will go 2 such divisions to the left. So that becomes minus 2/4. Do you see? And the y value is minus 2. Well, if I go with fourths, this scale is going to stretch quite a bit. So on this scale, I will use a different scale. So I will not use 1/4 here because 1/4 will mean 8 1/4 to go here, right? So like, okay, so that be 1, 2, 3, 4, 5, 6, 7, 8 beyond the limit. So being practical, what I will do here is use a scale which is like this. So my x-axis scale is of 1/4. Let me write here 1/4 on both the side. And my y-axis scale will remain as 1. So I can take slightly bigger ones just to be convenient. Okay, let it be like this. Okay. So that is my 1. So these are my like 1, and this is my 2, this is my 3, like that. Okay, this is my 1, that's my 2, and that's my 3. So those are my 1s, okay? So we can always have a different scale on both the axes. That's not a restriction. So you can always change your scale. So x, and this is my y-axis, and here we have origin O. Now let's get back to plotting the point. So this is minus half, which is minus 2/4. So we go 2/4 left, and minus 2 means 2 units down. And I'm using this as 1, so I go 1 and then 1 more. So that is my point, which is point A, correct? How about point B? 3/4. So we'll go this 1/4 three times. So 1, 2, and 3. So that is my 3/4 and 3 units up. So 3 units up means 1, 2, and 3. So there we are, correct? So if I join these 2 points, I get my line AB, right? And line always extends on both the sides. So I will just draw it like this and go up and like this. Okay, so we have a line. And let me clearly write what my points are. So these are my points here. Point B is 3/4 and 3. And point A is -1/2 -2, right? We are not doing calculations, so let's write the original points. Okay, that's how it is. So in my scale, this is 1, this is 2, right? This is 3. Just a reminder for you, this is -1. So it's like -1, -2, and this is -3. So my y scale is kind of different, right? And this is my -y. And this side is always -x. So that's how it is. And I kind of have a figure here. And this figure shows me one thing very clearly, that the slope is positive and the line is rising. Okay? Now let's do our math. And that is find the slope. So we need to find equation of a line, and we are working on this with line in the form of y equals to mx plus b, right? Where m is the slope and b is my y-intercept. So let's find slope first. Slope m is rise over run, which is y2 minus y1 over x2 minus x1, correct? y2 minus y1 is this difference, right? 3 minus -2. So which gives me 3 minus -2. Thank God, numerator doesn't have any fraction. Now comes the denominator part. x2 minus x1, that means 3 over 4 minus -1/2. Isn't it a good idea to write this? Let's write this. So minus of -2 over 4, right? Even otherwise, you have to make common denominators and you have to write like this. So why not do it beforehand? Correct? That's the whole idea. Now it is simpler. 3 minus -2 gives me 3 plus 2, which is 5. Divided by, now they have common denominators, so we can do straight math, right? So it becomes 3 plus, or let me write one more step, 3 over 4 plus 2 over 4, right? So that's not that difficult, right? So this gives us a value which is equal to 5 divided by 3 plus 2 is 5 over 4, correct? Let me push this page a bit above so that it's clear to you. 5 divided by 5 over 4. Okay, now since this is kind of fraction, let me move it here and show you how to do this. So we have slope m equals to 5 divided by, so let me write this, 5 divided by 5 over 4. That means this is equals to 5 multiplied by 4 over 5. Is it okay? Divide and multiply means reciprocal. Flip it, right? So when you flip it, 5 and 5 cancel out, you get a slope of 4. Isn't that interesting? We started with tough, numbers, but got a simple, beautiful answer. Slope of 4. Perfect. Now we know the slope of 4. This will help us to find the y-intercept, b. So how do we do that? Let's rewrite the equation with this slope, which is y equals to 4x plus b. To find b, we need 1 point. Both have fractions. Let's take 3 over 4. 4 will cancel out. So y value is 3. Let's write 3 here. Equals to 4 times. And what is x? X is 3 over 4. Let's write 3 over 4. Plus b, correct? Now 4 and 4 cancel out. And we get 3 equals to 3 plus b. Good job. 3 is equals to 3 plus something, and that something should be 0. Only then 3 is equal to that, right? Or you can say b is equals to 3 minus 3. Perfect. And therefore, we get 0 equals to b, or b equals to 0. So that's a very interesting case. And it looked like, oh, it went through origin. So this time, the sketch was very good. Very good. Okay. So let's summarize what do we have. So I'm running into my diagram and I'm going to write like this. Clearly show you what we have got. We got a slope of 4, let's say m equals to 4. And my y-intercept b is equals to 0. And therefore the equation should be, we want it in the form of y equals to mx plus b. M is 4, we write y equals to 4x plus 0. So 0, no need to write. So we get y equals to 4x. That is interesting. If we don't have any value plus or minus with 4x, it means what? It means couple of things. Let's summarize all these things. Can you help me doing so? First, line go through. So that means origin is on the line. Let me write like this. Origin, the point of origin, that is 0, 0, lies on the line. Is on the line. That is very important, right? So origin is part of your line. You can find all other points on the line by putting different values of x. If I write x is 1, I get y4, x2, y8, x3, y12, like that. All other points, correct? Okay, you'll see, is it 4 times this? Yes, it is. Is this 4 times this x value? Yes, it is. So the y value is 4 times x value, and that is what you get, right? So 1, the line goes through origin. Second, b, the y-intercept is 0 for you, correct? That is what you get. And this is an application of direct variation, right? You remember doing direct variation? Direct variation is when a straight line goes through origin, correct? That's how it is. Thank you.